Hello, in this lesson we're going to be looking at plotting a quadratic curve. So we're going to start with a recall exercise. Could you pause the video and see if you can write down the first 15 square numbers from memory? So you should have got these. If you don't know them, then you can work them out. For example, the first square number is 1 times 1 equals 1, and the second one is 2 times 2 equals 4, and so on. But it's really helpful if you know these off by heart. So if you don't know them, you need to learn them up to 15 squared. Okay, so what happens if we square a negative number? So for example, if I take negative 2 and multiply it by itself, I'm going to have a negative multiplied by a negative, which will give me a positive. So negative 2 squared is positive 4. So when we square a negative number, the answer is always positive. So if you are going to use your calculator for squaring negative numbers, you have got to be really, really careful. You're going to need to put the negative number that you're squaring into brackets. So if you want to try this on your calculator, if you put in minus 4 squared, as you can see in the first case just over here, your calculator will tell you that this is negative 16. Whereas when you put brackets around it, it knows that you're squaring negative 4, not just squaring 4 and then making it negative, which is what it thinks you're doing here. So here it will give you the correct answer. It will tell you that the answer is positive 16. So when you're squaring negatives and you're using a calculator, you have got to be really careful. Use brackets. Okay, so we're going to start by plotting the most straightforward quadratic curve. So by quadratic, I mean that it has a power of x that is a square power, and that's the highest power of x, because we could have x cubed, for example, that would be a cubic. So when the highest power of x is x squared, that is a quadratic. And so we're going to plot the graphs of equations with an x squared. The most simple of those is y equals x squared. So this is telling us that the y coordinate will be the square of whatever the x coordinate is. So we're going to start with the positive x values first of all, and that's my tip in general. Start with the positive values of x. You're less likely to make a mistake with those, and there is a certain amount of pattern in your answers which you'll then be able to use to check your negative answers. So first of all, y is equal to 0 squared. That's 0 times 0, which is 0. So that's going into my table there. Next one, y equals 1 squared, which is 1 times 1, so that's 1. And then y equals 2 squared, 2 times 2, which is 4. So if we know our square numbers, this is easy enough to fill in. We're just squaring the x values, and that gives us the y values. So now I'm going to move on to the negative side, and I'm going to do minus 1 squared, so minus 1 times minus 1. And I've got to remember that that is positive 1. And then for the last one there, y is negative 2 squared, so negative 2 times negative 2, which is positive 4. Now you can see what I mean about there being a certain amount of pattern, because what we've got here is some reflection of the values, because the negative values, when I square them, will give me exactly the same answer as when I square the positive values. So now I've got pairs of coordinates here. I've got 0, 0, 1, 1, and 2, 4, and I'm going to plot those, and then I've got negative 1, 1, negative 2, 4. So I'm going to plot those coordinates. And what you'll see is I get this sort of symmetrical curve here. Now, it's really difficult for me to join these up nicely, but we do need to join them up with as smooth a curve as we can possibly manage, and you will need to do that with your pencil. Now, the easiest way to do that, actually, I think, is to turn the graph upside down, because then you can use the natural sort of arc of your hand. If you try and do it as it is here, it's quite difficult to do that smoothly. What I've done is I've used a graphing package to show you what that should look like when it's complete. And all x squared graphs, x squared type graphs, will have this sort of shape to them. If it was negative x squared, it would look very similar but upside down. And they all have a line of symmetry. In this case, the line of symmetry happens to be the y-axis, but that's not always the case. And I've just pointed out that this point at the bottom here, where it stops decreasing and starts increasing again, that is called the turning point, or sometimes the vertex. And you might sometimes hear this called a minimum as well, because in this case it is the minimum point on the graph. Okay, we're going to try and plot a slightly different quadratic curve now, and we're going to look at y equals x squared subtract 3. So again, we're going to start with the positive x values because those are easier for us. And the first one is going to be 0 squared subtract 3. So 0 times 0 subtract 3. 0 times 0 is 0. We're going to then subtract 3, and so our y value will be negative 3. So what I'd like you to do is pause the video and see if you can work out what the values will be in the rest of the table. Okay, so completing the positive values then, we're going to have 1 squared subtract 3. In other words, 1 times 1 subtract 3. And that will be 1 subtract 3, which is negative 2. And then the next one, 2 squared subtract 3. So 2 times 2 is 4, and then when we subtract 3, we will get 1. So those are the positive values, and now I'm going to work on the negative values. And you can see I've put brackets in here. If you use a calculator, you will need to do the same. So negative 1 squared subtract 3. We know that negative 1 times negative 1 will give us positive 1. So we'll have 1 subtract 3, which will give me negative 2. And then finally, negative 2 squared subtract 3. Negative 2 squared will give me positive 4. And then when I subtract 3, I'll get 1. So again, you can see that there's some symmetry in these values here for the y coordinates. I'm now going to plot these points. So negative 2, 1. Negative 1, negative 2. 0, negative 3. 1, negative 2. And 2, 1. And again, we need to join those up to create as smooth a curve as we can. Now again, this particular example, as it happens, the line of symmetry is the y-axis. That won't always be the case. And I've used a graphing package again to show you what that looked like once you've joined it all up. And we talked on the last example about how this point at the bottom here is called the turning point or the vertex. And we've got some additional vocabulary you need to know here. The roots. Where your graph crosses the x-axis, which is right here and here, these points are referred to as the roots. Okay, they are the solutions for when y is equal to 0. Now we didn't have that on the first example because actually it never went below the x-axis, so there were no roots. Okay, this is an exam question. So I would like you to pause the video and see if you can answer this question, knowing what you now know about roots and turning points. So pause the video and give this a go. Okay, so first of all, the roots. That is where the graph crosses the axis here. So it's the x values that it takes here and here. And so we've got to be really careful reading these off because they are going to expect us to be very accurate. So right here, this is where 3 would be. So that means this here is actually 3.2 because there are only 5 squares between 3 and 4. So 3.2 is one of the roots. And then we've got this one here is where 1 would be. So this is negative 1.2. So 3.2 and negative 1.2, those are the roots, and they are the solutions for when the equation, which is given to you up here, is equal to 0. So now the coordinates of the turning point. So that is not sitting on the y-axis because this is not symmetrical about the y-axis. This point right here is the turning point, and you can see if you read up that that is where x is 1. And if we read across here, that looks to me like it is negative 5 because it's sitting halfway between this, which is negative 4.9, and this, which is negative 5.1. So we're being asked to give it as a coordinate, so that would be 1 and negative 5. Okay, we're going to look at plotting some more complicated quadratic curves now. So this one, 2 lots of x squared add 1. So when you're working out these values, you need to use BIDMAS. BIDMAS tells you to do indices first. So you're going to do the squaring first, and then you're going to multiply by 2, and then finally add 1. So BIDMAS says indices first, then multiplication, then addition. And so that's the order we need to do this in. So I'm going to again start with the positives. 2 lots of 0 squared add 1. 0 squared is 0, so that's 2 lots of 0 add 1, which is just 1. So I can fill that in for my table there. What I'm going to ask you to do now is pause the video and see if you can fill in the rest of the table. Okay, so next one will be 2 lots of 1 squared add 1. So 1 squared is 1, and so 2 times 1 is 2, add 1 is 3, and then 2 times 2 squared add 1. So that's going to be 2 times 4 add 1, which is 9. And then I'm going to move on to the negatives. 2 times negative 1 squared add 1. Well, negative 1 squared is the same as 1 squared. So 2 times 1 add 1, which is 3. And again, we can see that symmetry coming into play. 2 times negative 2 squared add 1 is going to be the same as 2 times 2 squared add 1. And that gives me 9. And now I'm going to plot those points. And that gives me my nice curve again. Again, no roots here because this is sitting above the x-axis, and this is what it will look like when I've joined up my points to create a nice smooth curve. Okay, more difficult again. So we're going to plot y equals x squared add 2x subtract 2. And I'm going to start with the positives again. So y equals 0 squared add 2 times 0 subtract 2. Now I strongly advise you to not try and work this all out in your head and to actually show the working like I'm doing. You can get away with it when it's just y equals x squared or y equals x squared plus 1, but you can't get away with it when you're dealing with a complicated graph like this. So 0 squared is 0, 2 times 0 is 0, and then I'm subtracting 2. So my answer here for this one is going to be negative 2. Could you pause the video and see if you can fill in the values for the rest of the table? Okay, so what you should have found here, y equals 1 squared add 2 times 1 subtract 2, and that's going to give us 1 add 2 subtract 2, which is 1. And then y equals 2 squared add 2 times 2 subtract 2, 4 add 4 subtract 2, which is 6. And here what you would have found when you did the negative values is you are not getting your line of symmetry about x is 0 anymore. So minus 1 squared, add 2 times minus 1, add 1. Well, minus 1 squared is 1. 2 times minus 1 is minus 2. And then we should have a plus 1 there. So this here should say plus 1. There's a little mistake here. And so when I work that out, I'm going to have 1 subtract 2, which is minus 1, and then subtract 2 again, which is negative 3. Actually, the mistake is here, not here. So this should say subtract 2. So your answer should be negative 3. And then finally, we're going to have negative 2 squared, add 2 times negative 2, subtract 2. So negative 2 squared is 4. 2 times negative 2 is negative 4. And then I'm subtracting 2. These 4 subtract 4 will give me 0. So my answer is negative 2. So here what happens is the line of symmetry is actually about negative 1. So when I plot my points, you can see that the line of symmetry is not about the y-axis, it's over here. And when I join those up, I get this sort of shape. So don't expect that always to be symmetrical about the y-axis. Okay, here is your work for today. You're going to need to pause the video so that you can work from the screen. It tells you how to draw out your axes between x between minus 2 and 2. your table between -2 and 2 for x, and your axes from -3 to 3 on x and -5 to 15 on the y-axis. And then you're going to have a go at plotting these questions 1 to 4, and then question 5 is a more complicated challenge question. Make sure you draw out a table and show your workings in full.